Hi, ladies and gentlemen. Just wanted to start today's lesson with a riddle for you. This is a riddle that some of you may have heard before, and here is my riddle. Which weighs more, a ton of feathers or a ton of bricks? I'm going to give you just a moment to think about that. Which weighs more, a ton of feathers or a ton of bricks? So how did you answer that question? Clearly, there is a difference when we look at feathers and bricks, and here is the answer. Of course, it's a trick question. A ton of feathers and a ton of bricks, they have the same weight. They both weigh a ton, which is 2,000 pounds. But when we look at a ton of feathers and we look at a ton of bricks side by side, we can see that there's a very big difference between them. And that difference, of course, the difference is going to be the volume. And by volume, I mean the amount of space that the feathers takes up is going to be much, much more than the amount of space that the bricks take up. And so why is that? Scientific answer would be that a pound of feathers is much less dense than a pound of bricks. And so what is meant by dense? Maybe you have heard the word density before. And if you have, density is precisely the topic that we're going to be working with here over the next week to a week and a half. And so, density. Well, I guess one way that it's common to describe density is to describe it as a measurement. And so, density is a measurement, but it's really a measurement that relates to other measurements or properties that we have already talked about in this class. And these are two properties that are most often used to describe matter. And so the two properties that I'm talking about are mass, and the second property is volume. And mass, as you well know at this point, is the amount of matter that an object or a substance contains, whereas volume is the amount of space that matter takes up. And so density really is just a way we can put these two units together and we get a new property. And this new property turns out to be very handy for us. We can use this new property that we call density to really identify things and substances that are unknown to us. So I suppose I can go ahead and show you how these two properties, mass and volume, are related to each other through density, and it is by division. And so when we look at density, well, all we have to do to find a substance or an object's density is use the formula mass divided by volume. And so, of course, we can find the mass of an object. We can find the mass using a triple beam balance. And the volume we can find in a number of ways, but the most common way we found it here in class is by using a metric ruler and then multiplying using that formula, length times width times height. And so, sort of to summarize that, we find density by dividing an object or a substance's mass by its volume. Now, while mathematically that is very handy, and we will use that formula to calculate a substance's density, what is maybe a better way to think about density, in my opinion, is to think about what it really means. And when I think about density, I start thinking about how crowded or how tightly packed the matter or the atoms in a substance are. So how close together are the atoms? And so I think when we start talking about density, it's also very handy to think about it in terms of what the atoms are doing. And so if we look at these two containers, container A and container B, we can see that container A is shown as having high density. And so high density, as we look inside of this container full of nitrogen atoms, we can see that there are a lot of atoms in there. There's a lot of matter in there. And as a result, inside the container, there's very little empty space. But when we look at container B, which is shown as low density, container B just has a few atoms in there, and it has a lot of empty space. And for me, this is a much handier way to think about density. I like to think about it as how much matter and how crowded that matter is. But when we're trying to decide if something's high or low density, we can just look and see and say to ourselves, well, how much empty space in there? How much room is there for more matter, for more atoms? And so this turns out to be, I think, a much better way to understand density. Now, when we talk about density, it's not just related to matter and atoms. Density is used in lots of other ways. And so another way that we might think about crowding or being tightly packed is we could think about that with people. For example, we might think about urban areas, which are cities. And in urban areas, we have lots and lots of people that are tightly packed. We might say that they're crowded together. Whereas if we were to look at a small town or a small village, we're going to have just a few people. And those few people, they're most likely going to live much further apart. And so we can use density to talk about populations and people. Or we can use it to talk about atoms. So density turns out to be a very versatile word, and we're going to be working with this for quite some time. So I hope you've learned a little something about the beginnings of density, and I look forward to talking to you guys again soon.